So thank you very much for the kind introduction. We have prepared a talk about semantic data transformation and ecosystem based on CKAN. We have 4 speakers today, and on the next slide, I will show you what you can expect from today's presentation. So I will give a very short introduction into our project, just so you know what the project is about and what the goals of the project are. And then I will dive into ontology development workflow with OntoFlow, which is something that was developed by our project partners from Infi, and some are here in this round today. So I'm very happy that they joined us here. And then we will see something about the tool stack of CKAN extensions demonstrated by Thomas Hanke, and a demonstration of a new graphical ontology development tool, which is called RDF-D by Gordian Dziwis. We have also an optional part at the end. This is we base this option on how many discussions we will have. So our aim is to have maybe 15 to 20 minutes time for discussion. But if we don't need it, we will also have the opportunity to demonstrate a use case. As you have seen, we are not going to dive too much into really an ontology in the content. So we are not going to present really a class hierarchy or something that we came up with. We have published something, so I will point you to ontology, our ontology in the paper. But we want to more talk about how we approached generally the ontology development and also the data transformation in our architecture. So our project partners are listed here. We are 7 academic institutions that work together. And on the next slide, you will see why we need so many project partners. And we also have some industry partners that chaperone our project. Those are the guys and girls who worked on the project with us together. So there are a lot of people who contributed here, not only the people who are presenting today. And our goal is to represent the copper life cycle. So we really are focusing on a whole life cycle representation for copper and copper alloys. And that is exactly why we have so many project partners, because we aimed to have a representation of each step of this life cycle represented by our institutes. And we have also institutes that are working on the IT infrastructure. So not only the representation of the copper life cycle, but also on the ontology data room, ontology-based data room. And I want to present today our collaborative ontology development, our pipeline that we used in this ontology development workflow. This is how we started out in the project, but we used over the 3 years very extensively. And later today, you will see what we have learned from using this pipeline, which is already very usable, but where we saw something missing and where we have some improvements to present later by the talk of Gordian Dziwis. So as a lot of projects did before us, we started with a glossary and a collection of competency questions, also by the help of the ontology playground, which gave us a lot of governance during the start of the project, where all the competency questions of all the partners were collected. And we started off similar to, I think, many projects that we have seen before, where we started collecting terms and definitions of terms and our competency questions, and we have them in our GitLab or linked in our GitLab, where we work together, where we collect all those information. And next up, this is something that we used very extensively, is Draw.io together with the Chalk library to build actual graphs. Also for people like me who are not ontology experts or were not ontology experts in the beginning of the project, who really had trouble to understand how to use other tools or write turtle serialization. This is a graphical tool where you can build class hierarchies, you can build property hierarchies, you can express property relationships and triples, like you see in this picture. Here's an image of this chalk library where we already have some shapes that you can use, and you just drop them into your draw.io file, and then you have class hierarchies like here, where I just made up some hierarchy for you to see what this is about, like a subclass and a class relationship. And you can also express individuals that are attributed to a certain class. You can also build triples like that, object property class relationships. You can also express some kind of axioms, like if something is to be disjoint or else. If you want to dive deeper into this, I have a link for you where we also have a tutorial that Thomas was so kind to share with us. And to make this work, you also will have to define certain namespaces and metadata. So who is the creator of the ontology or the graph, and where are the namespaces of the resources that you use in your graph. And you can see this over here that we, you can see it already that we use a lot of IOF entities and QDT. Then we have MSEO content in our graphs a lot, and the BFO ontology as top-level ontology we also used very extensively, but not exclusively. So, and this is then an example of an actual graph that we built with the use of top and mid-level ontologies, and then added to with our KupferDigital ontology on the application level. And if you want to see this graph and browse it a little bit, you can follow this link over here. And you can then see the actual graph, and please not work on it, but you can have a look at it. And here I have just prepared one zoom so that you can see what is happening here. So we have an ADX specimen that is identified with an ID that has a function because it is meant to be measured in an ADX measurement, and then you have some qualities attributed to the sample and so on. And so you go through this graph and you will have a lot of information about what is happening in this ADX measurement, and map this the data that you are recording to this graph. And then you just put it into this link. You can follow this and try it out, where you then get the turtle serialization out of such a graph. But in our case, we also we have this already included in a complete workflow in our GitLab, and you can see in this paper here how this is working. So in our GitLab, there live already the draw.io files, and there's a CI job triggered as soon as you have a change on your graph, and the CI job will put this through this workflow where the turtle serialization is realized. You have a documentation and you have error reports. This looks like this. We have batches where you can see or if your transformation has failed or if it was successful. So I should probably take care of those graphs in the near future because there's something wrong with them, but all the others seem fine. And what you have in your GitLab are some batches like this, where you can click and have a human readable HTML visualization, and the turtle serialization is also created automatically, and you can have it just by clicking on this batch. And then you also have error reports. So there are, Hank, I think you're muted. And I think, I should hurry up. Yeah, I'm almost through. So this is it. You can follow this link to our paper that we published together. And just one thing that I want to mention here, we have some problems when we have those error reports. They were not very well readable, and that is something that we took care in the past, namely Gordian Dziwis, who will show us how this is resolved. So thank you very much for my part. I think Gordian wanted to jump in and tell us a little bit about the architecture so that you have an idea what we are talking about next. Gordian, are you there?
Well, he was before.
Yeah, maybe.
When he's not there,
okay.
Maybe I can tell something about
just,
this.
Yeah.
So yeah, this is some kind of overview, which is still dynamic, which is showing most of the architecture we're aiming for. So in the top, we have so domain-specific workflows. This is some of the parts that also
from today's presentation
on how to transform semantic data. There's also other workflow, which is now today in our show and tell optional, that could be shown by Matthias Weber, which involves another software piece, the DSMS from Fraunhofer EWM. Then we have the central part, which is about a CCAN, which I will show you something. There are data sets in there, which can also involve RDF data sets. There will be some mechanism transferring them into a triple store, which is not yet done completely. But I think we will finish this in a short while. And of course, if you have some data in a triple store, you can do additional stuff. You can have sparkless, which is mentioned here, which is giving you the opportunity to use human readable sentences which are then transformed into Sparkle queries, where you can see what's actually in the data, which makes it more easy for the user to apply this. Rhizoma Eye is also a visualization piece of software which will work on triple store graphs. Yeah. Then we have the onto process things. This is several modules which take care of mapping RDF, interlinking stuff, reasoning on them, which can also be done in the triple store, but sometimes it makes more sense to do it on the files first of all before you load it into the triple store, because you want to validate this as well. Then we have our GitLab. Miriam showed this already. We have graph templates, we have ontologies there. We planned on having shackle shapes, which is not much the case now. And that's actually it. The last thing that is missing is on the left side, the DCAT catalog harvester, which points to a EDC. With EDC means in that case Eclipse Dataspace components. And what is actually meant there is that we have a connector which is based on that software components, which offers us confederated DCAT catalog of all the content that is available in a data space, which as me as a participant has access to. And when we can also harvest this, we can integrate it into our local CCAN, every data we have access to, which is a cool thing. That's it.
Thank you so much for jumping in. And I would like to hand over to you entirely, because now we would like to show you the extensions for the CCAN that take care of an automated process where our data are mapped to ontologies, and where we also store mapping files that can be created by a user and reused as soon as you upload a similar data file to the data set. So thank you, Thomas.
As you might not know CCAN, but that's why I was putting up the official website of CCAN. So this is one open source data management system which works for file-based on actually, but which is used by many open data initiatives and also a lot of initiatives providing data for governments. So maybe keep that in mind, because that offers some opportunity, because we are generally funded by government authorities. Okay, we have a running instance of a CKAN deployment of KupferDigital, which you can find here, so everybody can actually find this. It has not all the plugins now in that deployment that I will show you. We will redeploy a new version when the development is in a state which is stable and everything works. So the most of the extensions is still in a staging area, so or staging status, which is not yet deployed for the whole public. What you will find in a CKAN, usually it's all centered about data sets. So you can create their data sets, with a lot of files, and if they are public, I can see them. And there's some information about this. CKAN can automatically add a lot of metadata. So as you may see, it knows already that this is a CSV file, this is a JSON file, and so on. And it also has more data about this, which I cannot show now. Yeah, I can. Yeah, so this is a format, a license maybe. And you can add a lot of metadata to this. And also, if you create a new data set and upload this, some data, you can manually add metadata if you want. You can have that organized in with organizations. So these are the organizations working on our. We have also the test organization with null data sets. So you see, we're still working on some stuff. And as long as multiple people can create something, also sometimes some test instances pop up. We have groups here where you can sort your dataset files in another way. So we had some groups here now: machine files, mapping, results, process graphs, which was shown already by Miriam, and we have some mappings. I will switch over to some simple examples how actually our data might look like. And lately I had to create a tutorial for the IOF community, which is also kind of valid in our domain, except it does not use PMD core ontology instances, but is very close related to BFO and the PMD 3.0 developments, because the IOF is also having the BFO 2020 on top as top level ontology. And please don't go into detail with what it means to use those IOF concepts. That doesn't really come to play here now in the playground. So there are two tutorials here. One is very basic, which is explaining again what Miriam showed. How to create this stuff, how to do this. There are predefined patterns which you can use and adopt. And in the end, you come up with something like this, which is actually a caliper measuring in a process a specimen's length. And then you want to map your data against this. And there you usually have to create a mapping, and that mapping must be applied. And then you come up with a combined data set which involves data and also the graph you have created. And that is what the plugins I will show you are actually about. So this is my local deployment of a CKAN here with all the plugins deployed. And you see here two data sets, the basic one and the advanced one from the tutorial. And in there you find some very simple measurements look like this. So we have the ID of the measurement taken, and we have the length in millimeter. And the first plugin I'm show you. Takes a while. The first plugin I show you is actually the CSVW the CSV to CSVW plugin. It enables you to transform this kind of file into a metadata file which explains this one. So this can also be done live. So I can use another file, which is an example file for one of of the tools. So I can upload a CSV file from my, you will not see this probably, but I will pick a file from my local file storage here. So an example CSV, very sounding name. And this is quite actually an even relatively big example. It's like a tensile test. Oh, I cannot show this yet. It has a header and some data part with the table, so it has additional information. And what the plugin is doing is actually explaining this completely into metadata. So in the CSV file, there is a table group, and it has some nodes. There is an additional header. I can show you also this one, so maybe even easier to actually see those examples. So I use this example file. Looks like this. We have a header here, and we have some tabular data with multiple header rows and so on. And the first tool is actually taking care of this and is explaining everything which is in there. It also, you have seen I was not starting any workflow or something. It does it by itself. When a CSV file is popping up, it tries to transform this and upload this. You can also transform the whole table into RDF. So then the data is also transformed. For that more complicated workflows, you should with this you get no logging output, but it will say you that in the end it will be completed. The file has about, I think, 5,000 rows of data because it's a stress strain diagram involved. So it takes a while, but if that is finished, another file will pop up, which is having the whole table as a graph in there. Expressed in CSVW notation. That is what the one tool can do. It usually handles this data automatically. And then we have a second tool, which I can also show you with the basic stuff and also with the advanced one. This is map and transform. And that one is trying to apply mappings within a group, which is automatically created when you install the plugin. So you have to create a mapping, which is explained as a tutorial how that is done. It can be, it's a very readable mapping YAML file, which is then translated into RML, which is a state-of-the-art mapping language in semantic web. And it looks like this. It looks like this. So there's a mapping rule in there saying, oh, please iterate or through all the data. And if you come up with a column which has a name length millimeter, please create this triple. So it actually is simple as this. Might not be so simple for every user to create this, but that's where we have the tools for. And if you have such a mapping here, the tool is trying to apply mappings for every file I want to run this on. So if I want to run this here on that JSON file, I just go to run transformation. Now you've seen that was run already. I will just rerun the transformation that you can see what actually the output. And it tries to find a fitting mapping in that group of mappings which we have, which called mapping. And then it will rate those mappings concerning how many rules can actually be applied. So that is here. So it's only one mapping in there. So, oh no, it's two mappings, and it tests both. And it found that actually with one mapping, there is one rule to be applied. So that is the best mapping. And then it will just apply the mapping. And the result is the combined graph. This one. And that's actually what we do, what we want to do. So we have combined all our data, we transformed it completely, and then we have it uploaded also in a data set where we can reach it again. And the good thing is also in the data, every tool that was used and when and by what software is documented as Profo entities. So you come up also with this. The last component that is actually kind of missing is how to facilitate. Therefore, we are currently having also a triple store in the background, which is Fuseki based. And then you can also try to query on this. So there's a next coming up extension, which enables you to just pick one of those files here or transform them automatically into a data set in a triple store and upload this. Re-upload this, update, delete, and all the other operations you want to do. The last thing I will show you is that CCAN is also capable of creating DCAT catalogs, which is a cool thing. So every data set in the CCAN is expressed in DCAT terms. And that is actually what we want to use to exchange data between different CCAN instances. And this is also what the data connector aims to provide. So you will get from a data connector such a file, which actually says where the stuff you can actually have access to can be reached. And those things can then be harvested by a CCAN. I think I'm on top of the time. So I can just show you live how actually in harvesting should work. So you have
Thomas, before you enter the live demonstration, I saw one single hand up. I want to ask Wolfgang, do you want to do that now?
I can also do it later. I mean, if you want to finish, I'm totally happy that he finishes.
So. So just remember the state and we go with that. Thank you.
Yeah, that's the last thing I will show you. It will so you can configure a harvesting job where you actually point at the DCAT catalog you want to harvest, and then in the background a job is running on this. You see now it has 5 data sets identified. I was running this on my local DCAT catalog here provided by that instance itself, and now it will result in duplicated data sets here, which is not the case you want to use it for, but they will be enriched already. This is the wrong one, duplicated. And they will be enriched with additional data, which is defined in that DCAT application profile we are using here. And in the end, the plugin is also so configured that in a Fuseki instance, in the background, there is 2 data sets here, one inferring data set and one default data set, where that DCAT catalog is put. And then you can use Sparkless, which is also deployed with this stack, to query on this. You just have to point at the right Sparkle endpoint, which is in that case, or something like this. And then you come up with all the data sets you want to see. So give me every distribution, and then I want maybe, I don't know, multi-selection. I want the formats, I want the title, I want the media type, I want to know when this was modified. And then you can come up with such queries, and then you see all the stuff. So imagine if you have some more metadata explaining you what that is actually used for and what PMD-CO ontology that is compatible with, then you can find all the stuff you can use in your context and might be even interoperable. And I think that is the last thing I want to show. Maybe only one more thing. The whole data stack I have shown you is the development repository is here. It's having a development branch where you find something more. and that we can work on. So if you want to collaborate on this, then we can work also on this. That's it.
Okay, Thomas did those mappings, and this here, for example, is like a process graph which is used for these mappings. And we have built in the KupferDigital project a lot of those process graph, and the boxes or the layout here, or we use chalk for this. Like chalk is normally defines diagram elements which maps to OVL structs, and so you can like define ontologies in your diagram. What like normal the A box, like RDF data, is like a subset from this. So we misuse kinda the chalk diagrams for generating like for generating instance data. Now, these chalk diagrams, they have some problems. For one is a problem, they are visually not very expressive. So I think it's quite difficult to understand this graph here, because you have a lot of different errors which connect to each other, and they are actually needed because you want to express the process, how it was structured, and there are a lot of connections. Another problem is, does anyone see an error here in this graph? Okay, it's a trick question, because it's possible to see it. For example, like this edge is not connected, and then everything breaks. And when you have a lot of edges, this can happen very fast. So what I did in the last months, I took the idea from chalk and introduced it to RDF, because we mainly did only instance data, so we didn't need OVL in our we didn't need any OVL constructs in our process graphs, so it was enough to do RDF. So I tried to I used Turtle as an example, and so I kind of like took the syntax from Turtle and transported it to diagrams. And for a visual example, what comes out, I redid this graph with and made an RDF diagram out. So it's like this graph is like semantically it's completely the same graph, but with the RDF diagrams you have more options to represent stuff. And the main thing is you have just containers. Like you can put stuff in containers, so you have a more a tree view. Like here in this container is a tree, so you can the parts of your graph which are actually where the data structure is actually a tree. You can put in those boxes, and then it gets visual much cleaner. And also, if we implement here, for example, you see that the RDF live syntax check is on. Let's see, and if I now break something here, it should tell me that something is wrong. And I can also, like here, when I correct it, it puts out, okay, the window is very prototypey, but it puts out like turtle. So like you have a turtle file for defining RDF, an RDF graph, you can use like these diagrams to define RDF graphs, and which are, I mean, the layouting is also always a problem. Like the layouting the human has to be, it's like a very hard problem for a computer to do it. So it's not possible to take or maybe I'm gonna try it, but I think it's hard to take a Turtify and go the other way and create out of the Turtify a diagram automatically for the representation, but the other way around. And the nice thing is here, like you can like create your RDF graphs, and it's kind of, we are working on the user friendliness, but you can you can like you can also hide elements and show elements. Let's see, it's too small. So you can hide visual information, what's also helpful to reduce the complexity. For example, I have hidden the type information of some triples. And the thing is, like, we used Chalk as a front end for this because it's kind of open source and it's not too hard to modify, but it's not ideal. Like the end thing would be like an editor for the diagrams, which is like custom made for creating RDF diagrams. That you have a lot of quality of life improvements that you can like change like this representation of a triple, like to, for example, to a representation with an edge. What I wanted to show is like, so we abstracted from the front end, and to make it easier when we have to later to implement another front end is like all the elements the front end has to understand. It needs to understand what a node is. Also a node with the label is node. There are name containers which can contain other nodes. A container is also a node. Also a container could be in a container, anonymous container, and edges. And for the layouting, there it's possible to turn the container around and align the children of a container height horizontally. And also you can collapse the container, like in this here. SVG export, the button is missing, so it's not could be both. This has to be changed. And so, but this is all like what the front end have to understand. So I think in next I will try to implement that you can export and import like other diagram languages or diagram syntaxes, for example, dot files. And then if you are able to come to this structure, you get all the RDF stuff from behind that. You can create RDF graphs like for free. And this works like this. Like, for example, if you have this simple node, then it's like analog, because I meant it's like in Turtle. You can have like in a node when the label is an absolute array. It translates then this part of the diagram to this triple. You can define a base array in the Sparkle syntax. Okay, this one is wrong. This is not a Sparkle syntax. Here should be a uppercase base without an it and a dot at the end. You can define your prefixes. And do I have it? Yes. And yeah, it's like commutator. You have the. You could also put here the formatting is I don't have like conditional formatting for the nodes. It's not yet implemented, but you could put inside any node in your diagram also just Turtle. So this could be I don't know if you have like a big structure which you don't need to be fleshed out, or so you can just put Turtle in. And so even the directives, the declaration of the directives, like it works it's just a box with Turtle where only directives in it. Then you actually can also
just
take.
A second.
Yeah?
Sorry, Gordian. We are at the top of the hour. Yeah, we are at the top of the hour. Any take-home message you want to add for the audience that's still here?
Okay, I assume it's quite the usage of this is like quite general. For example, you could use it in when you're defining an ontology and you have like an overview diagram of this ontology. You could define it with this RDF diagrams, and then export it in the CI job and check if the diagram in your documentation is a subgraph of your actual ontology.
It's a constraints checker. So are you doing it right? So your tool basically tells you, was this okay for my requirements?
It just puts out like valid RDF. And then if you have like your diagram as valid RDF, you can check if this RDF is of this RDF graph is a subgraph of your ontology. Or you could put it like in your documentation and like export then your documentation directly to the knowledge graph. So yeah,
exactly.